Good day and welcome to another edition of Zero to Hero in Python programming. Today we'll finish what we started in the last tutorial, which was lists as data type in Python programming. So we are starting today from augmented assignment operator. So if you remember, when we're treating data type 1 and data type 2, we said some things about plus equal to, and if I didn't reference it, they just learn it from here now. So span plus 1 is same thing as span plus equal to 1, so it can be span plus equal to 2 or something like that. So basically that. So these are the augmented assignment operators that we have and their equivalent statement. So let's say span plus 1, we have it has been same thing as span plus equal to 1. This one can be 2, it can be 3, it can be a string depending on the data type you have here, like that. So span minus 1 is same thing as minus equal to span times 1, like that, like that, like that. So whichever one you want to use, is it division, modulo, multiplication, subtraction, addition, you can always just if it still references the same span or references the same variable, so you can always use it like this instead of having to write the whole thing out over again. For example, see here now we have span equals hello, so span plus equal to word means hello plus word, which will give us hello world. So bacon equals Sophie. So bacon times, normally we say bacon equals bacon times 3, but here we just did bacon multiplied by equal to 3. So you just give us bacon times 3, which is Sophie times 3, which gives us Sophie. So like that. So method in Python programming. So method is the same thing as function, except it is called on a value. For example, if a list value were stored in span, you would call the index list method, which I will explain next. Yeah. On this list. So span.index hello, the method part comes after the value separated by a period. What do I mean by period? I mean this full stop sign here. So hello I audi as. So if we say span index hello, it will give us 0, which is the position of span, which is the index of hello in this span list. So same thing with as now. We have that. Then index audi in that list, we don't have audi, so it will give us an error saying audi is not in the list. So if we have Sophie and this like that, if we check Puka, so it's telling us the position of Puka, which is 1. So it will reference the first place Puka appear. We have double Puka here, but to reference the first place it can find Puka. So it start checking from here. So as soon as it finds it here, it will stop and give us the index position. So adding value to list with append and insert method. Okay, so basically here, if you use the append method, which is a method on the list function, on the list data type, once you use append, it will add whatever you have in this bracket at the end of that list. So if we run this, if we check now, you can see we have cat, dog, bat before, but now we have cat, dog, bat, mouse, which was appended. So it was appended to the end. But if you want to put to a particular position, the way we're deleting from a particular position the other time, so you can just pick the index position with insert now. Instead of append, you use insert. So you pick the index position you want to insert to, then you write whatever you want to insert there. So for example, here now, chicken will now be in position 1 instead of the dog that was in position 1 before. So that's that on that. So egg equals hello, egg dot append world. This will not work because the append operator does not work on strings. So this will take us to what we call, don't worry, mutable and immutable objects. But I will still treat that in this tutorial today. So removing value from a list. Remember, we're using delete the other time. So you can easily remove bat. So we're using index the other time. So you can easily remove the particular name now. Instead of the index we're using when we're using delete, so you can just do this. So to remove bat from this particular list, this one will try to remove chicken, but because chicken is not here, we say list remove x not in list. So chicken is not in the list, so there's nothing it can do. So it will just give you an error. If you remove cat here, it will automatically remove the first one. As I said the other time, Python starts counting and checking from top to bottom, from left to right. So whichever one it sees first is what it will remove, though we still have some other cards. So just remove the first one. Then sort method in Python program in list data type. So if you are sorting, just sort from the lowest to the highest. So that's, I mean, yes, from lowest to the highest. That's what it did here. So same thing with alphabet. We are sorting strings. If you check the alphabet and just sort them. So in case you want to sort from the highest to the lowest, the reverse is always set to false. So you can now change it to true now. So reverse set to true, and it will just reverse the operation. So instead of starting from highest to lowest, start from, I mean, from lowest to highest, to start from highest to lowest. So that's from Z to, instead of from A to Z. So, but if you want to sort numbers and alphabet, it will give you an error, because the greater than sign, that is the comparison sign, cannot be done on string and integer. There's no way to check the difference between a string and an integer. So it will give you an error there. But if you want to sort alphabetically, you have capital and small letters. So you first sort the capital letters, then the small letters. But in case you want it to sort just alphabetically without bringing the capital letters first and small letters later, you can just use this. When you use this, it will see everything as lower. So what it's doing is, okay, convert everything to lower. So it picks the A first. So you know it takes time to convert capital A to small a. So it will pick the small and then the capital A, then small z, capital Z, like that. So list like types like string and tuple. So we have other data types. We've treated strings. We've still treated tuple in today's tutorial. So basically, you can actually go into string the way we go into list here. But mind you, string is immutable. But you can see name 1 will give us what the alphabet in position 1. Name 2 will give us the alphabet in position 2, like that. So for I in name, so print this, so it will just give us that. So that's like just using for loop into a string, the way we use for loop into a list in the last tutorial. So mutable and immutable types. So basically what we mean by a variable type being mutable is a list is a mutable type. It can have value added, removed, or changed. However, a string is immutable. It cannot be changed. So that's these are the basic characteristics that differentiate mutable data type from immutable data type. You can add value to them, remove value from them, or change value in them. For example, see this string now. You know, a normal day we say we want to change position 7 in a list. To just change what's in position 7. But if we run this to give us error, because we can't change what is in a string. String is immutable, whereas list is mutable. So something like this now. So if you want to do something like that, it's something like slicing, the way we slice in list. So you slice from 0 to 7, then you add D, then you slice from 8 to 12 again. So if you run that, you now have Sophie a cat. No, it's supposed to be okay. Sophie a cat. Then I named the new one new name. So it will now be Sophie the cat. So that's basically that. So something like just replacing variables in list now. So let's say the way we did this, if we are going to do that the old way of doing things, as in going one step at a time, we just do delete what's position 2, delete what's in position 1, delete what's in position 0, then append 4, append 5, append 6. So that's basically what we did here. Just a breakdown of what happened there. So tuple data type now. The main way tuple are different from list is that, like string, they are immutable. So tuple can do virtually everything. Tuple is like a list, except that, okay, tuple starts with a open bracket and close bracket, while that's the curved bracket, while a list starts with the square bracket. So that's that on that. And tuple is immutable. So you can check the index. You can use index to call tuple. They are also sequentially arranged. You can slice. You can check for their length. You can have multiple data types in them, but you can't replace them. You can't change them. You can't add to them. You can't remove from them. So that's why we say they are immutable. Object does not support item assignment. You can see that. If you have only one value in your tuple, you can indicate by placing a trailing comma, that is comma at the end, after the value inside the parentheses. Otherwise, Python will think you've just typed a value inside a regular parenthesis. The comma is what let Python know this is a tuple. So in case you have a tuple that has just one variable inside it, just put a trailing comma after it, so it will be able to know it's a tuple. But if you check it now without the comma, it's still it as a string. So converting data type, so you can convert a tuple to a list. The way we are converting list to string, I mean we are converting strings to integer to float like that. So you can convert tuple to a list, you can convert a list to a tuple, so like that. And you can convert a string to a list too, to just pick the object. You know, we're able to pick indexes from string the other time, so it will just split it into the index positions. So referencing in Python programming. So basically, see this list here, for example, we have spam equals 0, 1, 2, 3, 4, 5. Cheese equals spam. So if we call cheese, the position 1 in cheese, change it to hello. If we call spam now, it would have changed in spam too, because cheese and spam are pointing to the same list. So in the memory of your computer, when you said cheese equals spam, your computer did not create a new variable, I mean a new list. It just referenced this cheese to that particular list in its memory. So whenever you change anything in cheese or change anything in spam, it affects the two of them. So that's what happened here. So passing reference now. So basically what we did here is just append. So we appended hello to this list. So when we printed it out, it just added the hello. So it's something like what we did here. Instead of just replacing, we appended. So you can see we appended hello inside this function, whereas it's still affecting our spam. So that's that on that. So that's like using the function append on the spam itself, whereas we are using function egg now on the spam, which is using function append. So something like that. So it's still referencing the same thing in memory. So passing references. So the copy method, the copy module, which has the copy and the deep copy functions. So in this tutorial, I will explain the copy. You can try out the deep copy yourself. So basically, what we are doing, okay, you know, Python just points to the same list in your memory when you use something like cheese equals spam. But now if you use copy, instead of just equal to, you use copy.copy and you copy spam to cheese, Python will now create a new list called cheese. So if you replace anything in cheese, it will not affect spam. So for example, we've replaced first position here with 42. So B is supposed to have changed to 42, but you can see it's not affecting spam because we copied. We did not just reference. So if we now check cheese now, cheese has 42. So that's that on that. So if the list you need to copy contains list, then you can use copy.copy. That is, when your list has lists inside it. Let's say you have, the way we referenced a list that has multiple lists inside it in the last tutorial. So you use deep copy instead of the normal copy. So it will copy the inner lists as well. So that's that on that. So our assignment for this tutorial is try your hands on this assignment, and mind you, attempt the assignment in the last tutorial too. The reason why we are adding this assignment is for you to actually practice what you've done, what you've learned, because if you just learn programming and not practice, it's more like you are not doing it. So see you in the next tutorial, and don't forget to subscribe and like this tutorial. Push your solutions to GitHub and comment the link to your repo in the comment section below. See you in the next tutorial. Thank you.